Hi everyone. We go to the last lesson of the limits. Okay, limit of functions. Um, this this is the last section we call limits involving infinities. Okay. When we talk about infinity, everyone can recall about the sign, right? The symbolic. We use this one. So infinity can be plus, can be minus, correct? So if plus infinity, the numerical quantity will getting larger and larger, right? And if negative, gonna be what? Smaller and smaller to infinite terms. So in this case, like now we come back to when you find the limit, when x approaches infinity, almost the same idea when you before, okay, see this one. Before we do limit, correct? Limit f of x when x approaches, okay? But now infinity, instead approaches, right? We can find out x approaches infinity. Can be plus, can be minus infinity. Okay, now the graph on the right hand side here, we take a look. We're gonna find the limit, okay? So now if on the question, I ask you, say, find the limit of f of x when x approaches to, okay, it's 1, right? So you see this is a 1, right? So this is a x. So f of x when x approaches 1. So you can see if I don't have the sign plus minus on the right column, number 1. So that means we have to leave both sides, right? That lead the two-sided limit. So then we can do this one. The ways, I think everyone still remember how, right? So this one gonna be x approach 1 positive. Okay, that means we have to lead two-sided limit. Two-sided limit. Okay, then see this, if x approaches 1 positive, that means to the right hand limit, correct? So once right here, so the graph happen on the right hand is mean this graph, correct? So that means this one reach approach closer, 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 right to here. That's x1, x1. Then you can see this come up to what? Negative infinity, correct? This one plus infinity, right? And down here negative, and this one plus infinity, and this one minus infinity. So then you can from the right hand, right? So we find out this one approaches from the right hand equal to negative infinity. And then we can lead the limit f of x when x approach 1 negative to the left hand limit. So left hand limit of x number 1. So this a graph happen on left hand. So this one lead approach closer, closer to here. So that's also equal to negative infinity. So then you see these two from the right and from the left, they're equal, correct? So then this limit exists. So then this one equal to negative infinity. Okay. So now we try more. Okay. So before we may answer in this case, right? We may answer say this that does not exist, but now we can lead now approach to infinity. Okay. Now if I ask you say limit f of x, okay, when x approaches 3. Okay, then again, if I like only 3, that means we have to lead from left and right, correct? So this one, if limit f of x when x approach 3 plus, and limit f of x when x approach 3 negative. This one plus, okay? This is negative. So then you can leave where's 3 right here. So the right hand limit mean this graph, right? So this graph have to lead closer, approach closer, or approach closer to x equal to 3. So this is the plus infinity. So this one equal to plus infinity. And from the left hand, again, from the left hand of the x equal to negative 3 on this graph, correct? So you lead closer, closer to 3, so it's also plus. So now this one equal, okay? This one, this limit equal, then can say limit f of x when x approach to 3 equal to plus infinity. Okay, now we can try one more from the picture we have here. Okay, if I ask you limit f of x when x approach 5 plus So what equal to? So that means 5 plus, that means we have to read the graph from the right hand limit. So you see x equal to 5 right here. So the graph happen on right hand, this graph, right? This one. So this one reach up closer to 5. So then this one means equal to negative infinity. So equal to negative infinity. So if I ask you limit f of x, okay, when x approaches 5 negative. So what is going to be? Again, 5 here from the left, the graph on the left hand, it means this one. So this one is closer to 5 here, right? So this one become plus infinity. So this one, okay, if there's, in this case, that the different, right? So at the finally, if I ask you, say, if limit f of x when x approach 5, so what is going to be? So you can leave from here, right? So you, in general, you're going to answer what? Because limit is not equal, so then does not exist. Okay. So that's the way now. So now we can read if they approach to positive infinity or negative infinity. Okay. It's similar to previous learning, right? For it previous lesson, I mean exercise, you practice and you learn the same idea exact, but now lead up to infinity only. Okay, not only specific, so only C, but to infinity plus or minus. Okay, now next we try another example. To describe behavior of this, f of x equal to -5 over x power 4 near x equal to 0. That means this question they want to find limit f of x when x approaches 0. Okay, so we find asymptote first, right? You recall this. We find the asymptote, right? We can get asymptote, horizontal asymptote and vertical asymptote. So now we get the vertical asymptote first. How to plot graph, okay? Vertical asymptote. How to get this one? Vertical, that means you have to see from the denominator here, right? That means x power 4, okay? So we got right away, vertical asymptote is x equal to 0. That means shouldn't be 0, right? So we can see vertical asymptote right now here, the graph, this one gonna be broken line. Okay, so this line x equal to 0. Now you find horizontal asymptote. How to get horizontal asymptote? See the top, right? Degree, the top is what, like a half, x power 0 is equal to 1, so times 5 still 5. So you see if degree and the top numerator lower than denominator, the bottom, this power 0, power 5. So then we got horizontal asymptote that equal y equal to 0 also. So that means when you plot graph, this one gonna be horizontal asymptote. Okay, so if this is the x-axis, okay, this is the x-axis, so like this one. Okay, so the y gonna be 0 here. Okay, so there's a horizontal asymptote and this a vertical asymptote. Now, this one you can see we have x-intercept or not. Every time when you plot graph, right? This graph we call rational function, correct? Because a fraction, like a fraction, right? 5 over x power 4, something like that. So then next, if you plot graph, if question asks you, you have to do plot graph every time, okay? That's really help for when you find the limit. So next one you find what? X-intercept, correct? So x-intercept means y have to be 0, right? So if this one, f of x means y, correct? So x time, if y becomes 0, this time, so it's undefined. So that means no x-intercept. Okay, next step, how to do? Find y-intercept. That means x becomes 0, right? So x0, this one, see, y-intercept. That means doesn't have y-intercept because the x0, this one become undefined. So no y-intercept either. Okay, so from the graph you can see it doesn't have intercept and no y-intercept either. Okay, so now how to plot this graph? You just replace, right? because y equal to negative 5 over x power 4. So you just replace if x equal to 1, what's going to be, right? So going to be minus 5 over 1 like this. So keep plotting if x from the right hand side here. And the left hand side if x equal to negative 1. So it's always positive because of this one, correct? This on the bottom because power 4, so the bottom always positive, right? But the top here is a negative. So now the graph gonna be go like this, approach to vertical both sides. Because when you replace the value of x, no matter x is a positive or negative, they come up negative. Okay, this one even number, but this is a negative. So the graph gonna be like this. You can try plot by yourself. So this is the easy way. Remember, we plot graph. We find first step, if rational function. You find the vertical asymptote, horizontal asymptote, right? And then x-intercept, y-intercept. After this, then we form this graph, right? From this graph, we can find the limit of the function like the way when x approach 0. So that's gonna be what? Go down, right? So to this one is a negative infinity. So then the answer equal to negative infinity. Okay, so now I understand now it's because repeat again like before the previous lesson. Okay, so now we go next example. Look next example. Still the same thing. Describe the behavior of the function g of x equal to 8 over x squared minus 2x minus 8 near x equal to 2. So in this case mean this next example, okay. That means we have to find limit g of x when x approaches negative 2. Find this one. Okay. So again, this one we plot graph, right? I think everyone know how to plot graph now. This is a rational function, correct? So how to plot graph this one? From from g of x, right? You can simplify, right? First step is what? Find vertical asymptote, horizontal asymptote, x-intercept, y-intercept. And then you plot a few graph by side, 1 or 2 points enough. Okay, now we can simplify first, correct? Still do the same way. In this case, we try simplify first. The first step, you want to check replace x equal to negative 2 in here, everyone. So if they 0 over 0, remember, or infinity over infinity, the go next one is what? Simplify. If simplify doesn't work, then you use the table, or that means when you use table, that means approach choose the number very, very close to negative 2. Can be both sides, plus and minus, right hand side and left hand limit. Okay. So in this case, I want to factor first. Maybe can do it. Okay. So I will factor it. Okay, can we factor it now? Try. So x 4 2h, right? And minus this one plus. So 2h, yeah. So we can factor it. Okay. So after this one, when you factor it, you can see we can find vertical asymptote, right? So vertical asymptote become what? Vertical asymptote equal to x equal to 4 and negative 2, right? Right, just get the denominator here, the bottom here, everyone still recall, get below here, the whole thing here equal to 0, right? And then you solve for x, that's a 1. Okay, when you have, when we have this one vertical asymptote, now find horizontal asymptote. Okay, that means this one, if you simplify this one, you can see this, the top is the 8x power 0, right? Because x power 0 is a 1. So over the bottom, it's going to be x squared plus this one, x squared minus 2x minus 8. The top degree 0 lower than the higher degree denominator 2, right? This 0, this is a 2. So then we can have horizontal asymptote, which is y equal to 0. Don't forget if degree the top lower, yes, it's have horizontal which is equal to 0. If higher, this is another thing, okay? Higher have, if higher only one have slant because slant asymptote, okay? Like for example, I have x power 2 over x like this minus 8, for example. If this one have slope, we call slant asymptote. Okay, that means when plot graph can be like the asymptote can be linear, right? Because this one, maybe I explain this one later. Okay, so I will in the Zoom meeting I will explain this one. Recall, remind me how what about this one too. Now what we have next? Then we find x-intercept, y-intercept. X-intercept y equal to 0. So that means if g of x or y now, right, it becomes 0 times. So no x-intercept. Okay, because y, this one becomes 0, we do cross multiplication. So this is no x-intercept. Okay, now we find y-intercept. Y-intercept. That means x becomes 0. So replace 0, 0. So y become -1. So y equal to 1 here. Because when you replace this one 0, 0, 8, cut. So you have -1. So that means y-intercept, the coordinate point going to be x0, y1. Okay, now you can plot. Now you have x-intercept. That means no x-intercept and y-intercept 0 and 1. And you vertical. Now you can see this. Vertical asymptote is 4 and -2. You can see from the graph. Right now they plot for you already. -2, right? 1, 2. This is -2. 4. So this is a 1, 2, 3, 4. This point is a 4. Okay. Now y-intercept x0, y1 here. X0, y1. So this point is a y-intercept. Okay. This means 0 and 1 here. Okay. This is a y. Come here. This is a x. Okay. Now you plot graph each side. When you have this one intercept point. Okay. This one is the intercept, right? I mean, sorry, the asymptote, right? This is a vertical asymptote. And horizontal asymptote, so y equal to 0, that means exactly right here. I draw the green color here. This is a y equal to 0, that means equal to y equal to 0. And this one is x equal to 4. And this one x equal to -2. Okay. So that's the way you plot. Remember, you see the recall, right? Okay, now this is the intercept. Then after that, you just plot one more point in on this side, right? Recall, right? You can get like an x equal to 5, right? And then you replace in there, replace x in here equal to 5, x equal to 5, and see what the number come out. There should be positive numbers, so that's why they come up here. When you get x equal to 5 right here, right? So you get this point, right? So after this point, you know right away the curve happens to be on the top, on the above x-axis, right away, because we know this asymptote, so the curve approach close to asymptote. Remember the trick I used to tell you, and the less point I don't need it. It's just approximate, but we know it's happened here. Okay, so below here doesn't have because we have here already. Now in the middle, the same thing. This is asymptote. This is asymptote, because then the graph when you plot replace x to 1 on this side, right? And then this side x equal to -1, then you come out should be somewhere here. So then you know this is intercept. So it should be this one, because they will approach to asymptote. Okay, so the left hand side do the same way. Okay, so because most of graph, when you plot graph, they won't pass through the asymptote line, correct? So we can guess the graph is going to be. To take a look for this one, you will recall what we learned last year, okay? So I know once we have this picture, you can answer now. You can answer limit of g of x when x approach to -2 here, what's going to be? Okay, so you can see -2 is somewhere here, right? -2. So then you see they happen to graph by -2 here. This is a -2. So on the left happen this one, so become plus infinity. And the graph on the right -2 is this graph, right? This picture, they approach closer to -2. So this is a negative infinity. Okay, but this one is a plus infinity, correct? Sorry, this one. So this one on the left hand side, right? The curve or the function approach closer to -2 here. So this one is what? Plus infinity. Okay, so then in this case, you can see they happen in this way. So if they ask us about limit when limit g of x when x approach -2, this one answer with doesn't exist. Okay, if the question asks about this, if they are specific from the left from the right, that's the answer right here, right? You see this one negative, and this one approach to positive. So that's the same what we have here on the top and the bottom here. But if the question asks limit f of x when x approach to -2, no plus, no minus on the right corner number 2, you answer what? Does not exist. Okay, because they're not equal, plus 1 minus. Okay, so now go next example. This function, okay, this one. So if from this function, the question can ask you this one. They give you this graph already. This one we can just by f of x when x approach to infinity and limit f of x when x approach to negative infinity. So see this one, what the answer gonna be from the graph, okay? From the graph here, the picture below here. Plus infinity, right? So you can see from this positive plus, right? So plus infinity, so should be to this side, correct? So this graph is keep moving here, like this one. So this, can you just approximate here? You can count this is a -1, right? So 1, 2, 3, 4, 5, 6. This one is 6. So when limit of the function when x approaches infinity, so come to this side plus infinity. So this one you just answer what? Answer plus infinity. I mean, answer the value of y have to be 6, sorry. Because when you lead the limit, lead the value of y, right? So this from the right hand side graph, the picture keep going like this, approach to y equal to 6. So this limit is a 6. Okay, how about left hand side? Come to this side, the left hand side, right? Negative infinity. So this go there. And this one approach what? You see this is a 1, right? So then lead the value of y, this is a 1. So this one equal to 1 to negative infinity. Okay, this one just learn how to lead if they approach to infinity plus, and plus infinity and negative infinity according to the graph. From the previous example we just finished learning, right? Now we can conclusion the limit of infinity, right? The definition of limit of infinities. So actually exact same with the limit, the definition of limit. But now only is that x greater than a. Okay, let f be function that is defined for x greater than a for all number a. If as x takes larger and larger possible value, increasing with our brother, the corresponding values of f of x get very close, right? See that? We get very close and possibly are equal to single real number L. L is a value of y. Now, after you lead, and the value of f of x, that means y, right? Can be made arbitrarily close and close as you want. That means close as much we can, right? So to L, right? That means the value of y. We taking the large enough value of x. So the limit f of x that now this is important. So the limit of f of x as x approaches infinity to L. So you see L is just a y, right? You always, when we lead the limit value of limit, that means we lead the value of y. So now the difference is right here, right? Before is what? X approach to C, right? C is a all kind real number, belong to real number. C means belong all real numbers. Okay, but now still real number, but it's an infinity instead of only C. Okay, so this is a definition of limit at infinity. Infinity. Okay, now we go more example, I think, and then we go next one. Next example, you see this one. Describe the behavior of f of x equal to 1 over x as it approaches infinity. Now, the assign now approach infinity and approach as a negative infinity. Okay, so that means they want us to find this one limit f of x when x approach to infinity and negative infinity. Okay, that's what equal to, that's all. Okay, so now see, we plot graph again. Okay, see this one, f of x equal to 1 over x. Most of time we plot graph really can help, right? So this again, you find what? Vertical asymptote, horizontal asymptote, correct? Vertical asymptote become what? X equal to 0 right away. Because 0 is undefined, so this is gonna be broken line when you plot graph, right? X equal to 0. Horizontal asymptote is what? That means we have 1x power 0 over x, right? This less, right? So now y equal to 0 also. Now find x-intercepts. X-intercept. X-intercept. That means y equal to 0. Okay. So y equal to 0, this one, that means this one is a y, right? So y cross, so undefined again. So that means no x-intercept. No x-intercept. How about y-intercept? Y-intercept mean x becomes 0. So this one 0 become undefined. So no x-intercept either. Okay. So then you plot graph. See, we have vertical asymptote x equal to 0, right? So this right here, vertical asymptote. Okay. So this one equal to 0. And then you can see this horizontal asymptote y equal to 0. That means right here. Okay. So this is y equal to 0. Now, when you plot graph, we know right away it should be either on the top here, right? Because asymptote, 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 asymptote. So either on the top or the bottom. And this is asymptote. So it should be somewhere here or this one, asymptote. This is asymptote, so picture. So now plot graph, you just get one point enough, correct? For example, this one is a 1, right? So you replace 1 in here. Then you're going to get replace 1 there, okay? And then there should be a plus sign, so it should be somewhere on the top. Okay, and then minus should be, this one will replace x with a negative sign, right? So this one gonna be low here. So that's why the graph, the picture final gonna be this one, approach to asymptote. Okay, so that's everyone should know now about how to plot graph for a rational function. After we have graph right here, you can read now. If limit f of x when x approach to positive infinity, so this is one, right? We read the approach positive, right? So this one for here, right? For either one. But we leave the value of y, correct? So that's why we have here equal to 0. Approach to positive infinity, so this side, right? So you leave the value of y, so gonna be 0. When x approach to infinity plus, plus infinity. And when x approach to negative infinity, that means go to this side, correct? Go to this side. So then this one also y is also 0. That's why you have here. So this one x approach infinity, and this one x approaches negative infinity. So both of them answer the y is equal to 0. So that's the one, okay? So if the same answer, so if as this case, if as only say limit, this one limit f of x when x approaches infinity, it's the same, right? Because you have to leave plus minus, so they exist. Okay. Properties of limit at infinity. You see the property of limit. same like before we doing properties of limits. Okay, but let's now add this point infinity. Okay, do the property of limits, same thing like before, 1 to 5. The difference is what? Only this one again. Before, right, we have x equal to c. C is a real number. Okay, equal like this function equal to L. And this one also, right? Before we have x equal to c. But now equal to infinity. And the rest the same thing, writing exact same, just only here different. All the x approaches infinity from c become infinity. Okay, and the rest the same meaning, same writing exactly. Okay, so I think that's all from now. See you next time. Okay, bye bye.